What's up, guys? Welcome back to Code Porn. This week, I caught up with Josh Varty, who is the principal developer of the Alive project, which is a Visual Studio plugin that shows you exactly what your code is doing as you type it. Now, what does that mean? Well, you really have to see it to believe it. So I'm going to let Josh take over, and he's going to demo what the Alive project can actually do and how awesome it really is. But before we jump into that, if you haven't done so already, go ahead and click that subscribe button so you don't miss out on future episodes. Okay, Josh, take it away.
Sure. So sort of the problem we set out to solve when we built Alive was one that any programmer when we're writing code, we're manipulating data some way, whether we're making a mobile app or a line of business application or a game. At some point we're working with data, we're changing it, we're reshaping it, we're saving it. But the thing about programming is you never actually see the data. So all this data that we're supposedly working with, it's something that we have to imagine until we click F5 and run our program, and we can see sort of what we messed up or what we have to change. And this sort of seemed a little broken to us. If data is so crucial and important to programming, then it should really be at the forefront when we're writing or editing programs. So what we set out to do was build this tool called Alive that essentially shows you all of the data that's going through your program. I can start it up sort of in its most basic form here on a static method, and we can launch it and just pass in null for starters. And you'll see, like, as I add code, the results are shown in line right alongside the code that I'm writing. So we can go ahead and assign variables. We can manipulate these variables, and we can do some interesting things with them. So, for example, if we create a for loop here, we just quickly create a loop here. I better not use that variable again. Then what we get right away is this slider here that essentially lets us see the data at every stage of the for loop's iteration. And we think this is a pretty powerful idea because, a big part of debugging and figuring out what's wrong with our programs is going to be comparing the results and the data that we're working with at different points at time. So we've essentially mapped time to space here with this little slider here. And we can go ahead and create some interesting data structures. So if we just create a list here and maybe just put our results in this list, we can so we can sort of see if our temp is equal to my list. We can see what's inside of this list at every stage of execution and see exactly what's going on. Now, these ideas, we're not necessarily the pioneers in this space. These ideas have been explored in other tools such as the Swift Playground, which Apple recently released about a year ago, as well as Xamarin has a product out that does a similar thing. And there's been people that have sort of played around with this idea. And the reason these tools haven't sort of made the transition from toy to tool is because they've always struggled with state. So right here I'm running Alive on a static method, and it's pretty easy to imagine how we would invoke this method. But what about when we're working with data that's a little more complex? If we take two non-trivial parameters, how are we going to get data, and how are we going to make this tool sort of work with the regular programs that we're building every day? So what we did was we sort of looked at the code that our customers were using, and we decided we could run their code if we ran their unit tests. So what we can do is we can go here to maybe a more complicated function, and we can see here that we've got tests that are hitting methods, and if we jump to those methods, we can we can run those tests and get the results right in line. Test hello X, I believe, was the one that covered this one in particular. So, well, this one's not very interesting actually, because this one doesn't take any parameters. But if we just jump down here, we can run a test here. I'm not sure if test hellos probably hits this one. Yeah, so we can see right away that the data from our tests essentially flows through here. And we can even, compare different tests that we might want to run and see the results of running those tests against our code here. Once again, this is sort of a trivial example. This is a canned solution that we've built. So a lot of people want to know, how does it hold up in the real world? And one of the projects that we sort of test against is this Newtonsoft JSON. So this is a pretty popular project in the .NET world. A lot of developers use it. If you're doing any kind of web development, this is sort of got Microsoft's official blessing for how you're going to handle JSON. So I was doing a little testing here earlier. Let's just get rid of this method. When you're dropped into a project like this, you don't necessarily know which unit test is going to hit which method. So we've built sort of a way to filter these tests, and it allows you to map unit tests to their corresponding functions that they're hitting. I think the Newtonsoft JSON has quite a few unit tests, so this might take a minute or two. I think it takes about 60 seconds to run all their tests. So this might take a little bit, but maybe we'll jump to one of their tests and see if we can run it directly. So we can hit some tests in here and see what they're doing. If there's a test fixture, here's one. So we can run this test directly. We can launch our test directly if we want. And we'll go ahead and do that and let it build and get everything going here. So we've been working on Alive for about 4 months now, and we're aiming for a sort of a version 1.0 launch this fall. We're working with about 100 customers that have sort of, shown interest in the product and paid for the product. Right now we don't offer a free trial, but that's going to change once we hit version 1.0. We'll start offering trials. And a reason for, not offering trials when we started out was we really wanted to get sort of a core community of people who believed in the idea and were tolerant with, bugs and exceptions and whatnot, as we sort of shape this product and figure out how to, run anyone's code, because it's sort of a daunting problem if you think about the fact that you have to handle all these dependencies and all these different test cases and all these different test frameworks that a bunch of people use. So this method here should serialize class tag. We can go and we can, hop into other methods here, and we can, well, it looks like the test discovery did run, and it's showing that this method is covered by that test we were just in. So we can go ahead and run it against here. And this is sort of, a useful tool when you're brand new to a code base, or you're doing exploratory work with maybe a library or a framework that you don't quite understand. One of the ways we find it most useful is we work a lot with the Roslyn compiler. So the Roslyn compiler is essentially what allows us to build this tool in the first place. And we're working with this API that has thousands upon thousands of public methods. And, I don't think anyone outside of Microsoft fully understands all of the different parts and how they fit together. And Alive is really great for exploring and, testing things and iterating quickly. Because the moment you make a change, you can immediately see the impact of your change on the program and its results. We can just hop through here and sort of see what happens at different stages. Maybe I'll pop open a Roslyn project really quickly, and we can take a look at how Alive helps us there.
So this kind of looks like Oz code if you're familiar, if anybody's familiar with it.
I am familiar.
Yeah.
So I believe in debug mode they have just recently started showing inline some of the method parameters and the values that flow through your program. And this is similar in a way. The difference is their product functions at debug time. And ours functions, I guess, at what you would call design time. And what we're trying to do is we're trying to blur the line between those two. We want programmers when they're designing their programs to get instant feedback, to be able to change things arbitrarily, and immediately see the impact of their changes, so they can better understand what's going on. So I can hop down here to maybe one of our methods or one of our tests here. So if I run alive here, this is a static method, so it can be launched directly. We can see right away that if I just hover over the results here, we get this syntax tree that we've parsed. And if we go ahead and we make changes to this syntax tree further down here, without being familiar with Roslyn at all, you can sort of start to hover over these values and see maybe what Roslyn is doing. So we've got something here, it's called an if node. It goes through the tree, it gets all the descendant nodes of type if statement syntax, and we can instantly see that, okay, in our code that we were originally looking at, it looks like it's pulling out this piece. And if we go ahead and we start changing things to try and figure out what's going on here, maybe we want a method declaration syntax, for example. Oh, that's going to break all the rest of our code, but let me just comment that out really quick. Within a second, we can see, oh, that's pulling out methods. That's exactly what that does, and it makes it really easy to play around with. Chris Sells, he's a author of a number of books on WPF, and he said, it feels almost like IntelliSense for data to him. I believe he said that it was one of the best things that he's seen for C# since IntelliSense. So that's sort of what we were going at. Is being able to access this data within seconds instead of having to compile, run, place breakpoints or log, just to instantly be able to interact with your program and see what changes when we tweak statements and do different things.
Yeah, I can definitely see working with Roslyn. This would be just a phenomenal tool to have at your disposal. But let's talk about just the regular, average developer doing front end
Sure.
website stuff or just data in, data
Yeah,
out. How does
yeah.
this improve their daily tasks?
So for front-end web developers, this only covers C# for now. So you're going to be looking at your controllers and your models and your repositories. And if you've got unit tests that hit those, then you're going to be able to use Alive to hit experiment on these different portions of your code base. I know from my time working on some of those line of business applications or web applications, sometimes you'd get dropped in on a code base and it had tests. Some of them were passing, some of them weren't, and it was really tough to figure out how the parts all interacted together. And what we find Alive really useful for doing is exploratory programming. So you're dropped into this code base and you're trying to figure out how these parts interact. Well, just fire up Alive on a method and see what happens when you start tweaking things. Assuming you've done your mocking correctly and your tests aren't hitting your production database or anything, you should be pretty safe for working with data, manipulating data. Part of the reason we run unit tests is because this allows us to ensure that any code that we run is code that you deemed safe to run regularly in tests. If we were running your production code and removing things from databases or adding things for databases, we couldn't make that guarantee.
In the first example that you were showing, you were just showing setting up local variables and a for loop, but
That's right.
there's no unit tests for that chunk of code.
That's right. So let me just hop back there. So for very simple programs, we can run static methods directly, without having unit tests. So in a sense, you can use Alive as like a REPL. If you're familiar with Python and Ruby, a lot of these languages have these read eval print loop tools that allow you to execute one piece of code at a time, and you can do var x equals 5, and in your REPL it would spit out 5. Sort of the value of Alive is it's like a REPL on steroids, I guess, in a sense, because you can build up entire chunks of programs. If we just go back to what we had here, we can watch as upper limit is equal to 10. So if we just change our code really quickly, upper limit, we can see what happens when we change it to 100. Well, within seconds we're able to test different parts of our code out, and we're able to see how the code changed by interacting with earlier statements, whereas REPL, it's usually one line after the other kind of approach to programming.
Right. So at what point do you need to start having unit tests?
So you need to start having unit tests if you're looking to test classes that accept non-trivial parameters and aren't static. Basically, we run your static methods directly, but we can't run instance methods directly because we don't know what kind of objects your constructor is going to need, how to generate those objects. Do those objects only ever come from a database, or do they get serialized from an XML file? These aren't questions that we can answer statically. So we need you to sort of guide us with Alive, and Alive really is meant to be used by people who use unit tests. And today we support three of the most popular frameworks with XUnit, NUnit, and Microsoft's MS Test.
So as far as exploratory development goes, if you downloaded something from NuGet, let's say, and they don't provide the unit tests, then you're kind of SOL on that?
In a sense, like you could pull down NuGet, and then say you pull down newtonsoft.json. If you're able to start, maybe we can do that really quickly. Let me just bring newtonsoft.json in here. So without running newtonsoft.json, we're just going to bring down their package like normal, like anyone would. newtonsoft.json. I'll just install this one. So now if we hop back here and we want to, it's going to give us their site. And we want to, start using JObject, I think is one of theirs. Dot parse. Or actually, let's do dictionary string or test equal to new dictionary string, and we just want to add a couple things to here and then save it as JSON and see what that JSON looks like. So first is equal to first value, and second is equal to second value. So then we want to go ahead and JObject.parse. That's from string, so we want to load from object. So I'm going to test our JSON is equal to from object test, and right away we can see sort of what that JSON would look like. So you can play around with the APIs, provided they're somewhat simple. We walked through Roslyn's API really quickly, just showing how we sort of explore and learn this API. And you can do this all within the context of any static method. So, if you're ever working on a problem and you're like, I really don't know how this method call works, you can just fire up a new method, so static void new method, and you can just, launch Alive on it right here, and we can start, we can, quickly just put this stuff in here, and within seconds be able to see, oh, that's what that API does. So maybe I'll go back to where I was actually working and use it appropriately. You know, one place that we've been using this, or I used this today, was sample string, was using splitting strings. So if you have just a sample string and you just want to split it up, sample string dot split, and we'll just put a comma in there, and we'll split on that comma character. So we can see here we've got, you know, what happens if we have something at the end? Well, we've got three components to this split string. So for each val in split, we can see that, you know, there's sample, there's this sample, this garbage string, and then there's something that's blank at the end of this. So we can quickly, you know, go back up here, and if you take a look at the overloads really quickly, there's one of these overloads has a string split option, and we quickly realized that we could just use this string split option and remove empty entries, and now we've only got two values, and we've sort of you know, quickly solved that bug that normally we would have. You can't remember all the APIs for all the different things, so we normally would have hit that you know, when we ran our program finally, and it would have been sort of a facepalm moment, and we would have had to you know, return to design time, edit our code, then run it again, and you know, start dealing with the real business problems and the real issues that we want to get to.
Yeah, so debugging in general is a skill that has to be learned in the first place. And,
Absolutely.
you know, like I'm a big fan of Ozcode, but you still have to run the code in order to take advantage of those tools. And this is a huge step up from that for anybody, because again, you don't have to go through the compilation process, and you don't have to set your breakpoints and learn debugging, although you should.
Yeah. The same way you know, you have tools that, you know, make sure you don't make syntax errors, and you catch those within, you know, a second. We want to provide a tool that allows you to, in some sense, you know, catch, you know, dumb errors like this within a second. There's no sense wasting. If I had a big project here, like the project we work on as a Visual Studio extension, it requires like 30 seconds to start up and run every time. So if I started my program and then I realized, oh, I've split a string wrong, you know, that's now I've wasted, you know, a minute. And how often does that happen in the day?
Yeah.
So those add up.
So what is the magic that allows you to be able to do this? Are you using Roslyn?
That's right. Really, Roslyn is what made this, I wouldn't say possible. Technically, you could have probably, it would have been difficult, but you could have struggled your way through without Roslyn. But Roslyn made this, you know, an order of magnitude easier. The guys at Ozcode actually use Roslyn a lot as well, and they're active on the open source GitHub and whatnot there. Roslyn really lets us take your code, rip it apart, analyze it, and figure out you know, how we want to run it, how we want to profile the different values in your code. And without Roslyn, it would have been a lot more difficult to do what we're doing.
Awesome. So you said you're not at version 1.0 yet.
That's right.
Plan to release that in the fall. So what is missing in the current version that you plan to have in the 1.0 release?
So there's a few issues with this, and a lot of it has to do with performance. We want to run, you know, I showed really quickly when we were running Newtonsoft that we use this filter function to run all of Newtonsoft JSON's tests. We want to have parity with the speed at which you normally run your tests. We want to at least be able to run your tests at that speed. We're about, I think, 1.5 times. It takes us a little bit longer to run your tests as we profile and gather information about them. That's sort of like general performance. We have some issues with running really complex tests. So some people in their unit tests they're spinning up GUI elements, they're spinning up, yeah, if the, I know at Ozcode they have tests that spin up whole instances of Visual Studio. So if we're running their tests to run their code, we can't be spinning up and killing Visual Studio all the time. So we have to deal with those kinds of issues. In terms of features and functionality, there remains a lot of work to do with presentation and the front end and the GUI. It still has a long way to go. It's pretty early days here with a lot of this stuff. We also want one feature that we're actively discussing and trying to figure out is, you have these complex objects, this employee, for example, here. We think it's possible to get drill down the same way you get in Ozcode and Visual Studio Debugger and see the pieces of employee and see what's going on inside of employee and see those values. So that's another thing that we're hoping to get ready for 1.0 and something that our customers have been asking for, because the moment you start showing them values, you start to realize you almost want the full Visual Studio Debugger just all the time. So we've got a lot on our hands, but we're pretty excited to get there.
Excellent. And you have an official website for Alive, right? What is that?
That's right. So the product is called Alive. The website is called comealive.io. So COMEALIVE.io. Comealive.io.
Awesome. I'll put that in the show notes. Do you have
Cool.
a way for people to sign up for a mailing list so they get?
Absolutely. So I'll just pop on the site here. If we just go to comealive.io, right at the bottom of our page, if you're not ready to buy but you want to be the first in line for a trial, then just at the bottom of our page here we've got somewhere where you can sign up for email updates, and you'll get an email every time something major happens with Alive.
Dumb question, but this is not open source, right? So people can't contribute.
They can't, but they can contribute if they're a customer or someone who just wants to experiment. They can go to our GitHub issue tracker. So we have this issue tracker at github.com/codeconnect/alive-feedback, and here both our customers and maybe hopefully potential customers are interacting with us, and they're saying, I want this for Visual Basic, or I want this for JavaScript. And we do have some plans for supporting new languages in 2016. We have our first intern, and he's working on supporting a new language, so that'll be exciting.
That's awesome. All right, Joshua, I appreciate you coming on, showing us Alive. This looks like an awesome project. I fell out of my chair when I saw the demo video you have on the homepage.
Thanks, that means a lot. That's awesome.
All right, thanks to Josh for coming on and showing us the Alive project. You can follow Josh on Twitter at thisisjoshvarty, and you can also check out the Alive project at its homepage on comealive.io. All right, that's it for this episode. Be sure to subscribe to the channel, and if you like this video, go ahead and click that like button or leave a comment. Let us know what you think. Thanks for watching.